Hello. Hello everyone. Welcome back to the channel. So today we will be taking the look at this amazing problem called the K amazing numbers. So uh, try to pause the video and try to do this problem on your own, and if you're not able to get it, here's the solution. So the problem states that you're given an array A consisting of n integers numbered from 1 to n. Let's define the k amazing number of the array as the minimum number that occurs in all of the subsegments of the array having length k. Recall that a subsegment of A of length k is a contiguous part of A containing exactly k elements. So if there is no integer occurring all subsegments of length k for some value of k, then the amazing number is -1. So we have to calculate the k amazing number for k is equal to 1 to n. So our constraints are like n is up to 10 to 3 into 10 to the power of 5, and all of our integers in the given array are from 1 to n. Okay. So what I can notice is that this information that this information that array elements are from 1 to n is of some importance for me, right? So let us take a look at this sample test case. So these sample test cases are kind of weak, so I have designed one strong test case as well to uh, let you get the nice grip of the problem or understanding of the problem. So here is one sample test case. Okay, so for k is equal to 1, what I can notice is that for k is equal to 1, subsegments are indexed from 1 to 1, 2 to 2, 3 to 3, 4 to 4, and then 5 to 5. So here every number so there is not any number that is occurring in all of these subsegments, right? So for k is equal to 1, our answer is going to be -1. Okay, so what about k is equal to 2? For k is equal to 2 as well, our subsegments would be like 1 to 3. Okay, not 1 to 3, 1 to 2, 1 to 2, 2 to 3, 3 to 4. These indices are inclusive, 3 and 4 are both inclusive, and then 4 to 5. Again, we notice that there isn't any number that occurs in all of these subsegments. So for k is equal to 2 as well, answer is going to be -1. So answers are marked in these square boxes. So for k is equal to 3, my intervals or my subsegments are going to be 1 to 3, 2 to 4, and 3 to 5. So in this case, I can notice that this 3 is appearing in all of the three segments, okay, subsegments. So it is the only number appearing in all of the subsegments. So our answer for k is equal to 3 is going to be 3. What about k is equal to 4? For k is equal to 4, subsegments are 1 to 4 and 2 to 5. Here, so this subsegment is like 1, 2, 3, 4. This is like 2, 3, 4, 5. So these are the array elements. Okay, so these are the array elements. And what I can notice is that in both of these 2, 3, and 4, all these three numbers are occurring, but we have to take the minimum, right? So in question, they have clearly mentioned that minimum number that occurs in all of the subsegments. Okay, so for k is equal to 4, my answer is going to be 2. What about k is equal to 5? There is only one subsegment, which is the whole segment in itself. So 1 to 5, our answer is going to be 1. So basically for k is equal to n, our answer is going to be the minimum of the array, right? Minimum of whole array, right? So this is basically the questions. This is basically what question says, and let us look at the solution, how it goes. So let me erase all of these. Okay, let it be as it is. So let me take this part to some other place. So basically this is my sample test case which I have made. Wait, yes. So what I can notice here is that uh, suppose for some k, let's generalize, let's let's generalize our logic or whatever it is. uh, let's take a look at the values of k and its corresponding answers generally. Okay, we are going to generalize the terms. So for some k, let answer of k be x. Okay, answer of k be x. So what I am saying is that, so for some for some k there will be, for every k there will be an answer associated with this. So either x is equal to -1 or an element from the given array, an element from the given array, right? Absolutely yes. So what I can do is that elements of the array are constrained from 1 to n, right? So x is not equal to 0 and x can be -1 or x can be or x can be from 1 to n, right? So what I can do is that, suppose for some element x, uh, indices where x occurs, let them be i1, I2, I3, so on up to IR. Suppose on R indices, on R indices, value is equal to X occurs. Okay, so what I can say is that, so my K can be function of X, some function of X, right? So my K can be some function of X. So my K should be such that, my k should be such that k should be greater than or equal to I1, right? So basically what I'm trying to say is that, so suppose some indices are there and here it is I1th index, some indices are there, here it is I2th index, so on up to here it is IRth index, and so on up to n. So what I can notice is that, so if my answer is x and it appears first time here, so my k, if my k is less than I1, so suppose it is I1 minus 1, so when I choose this segment, my x is not occurring, my x is not occurring in this segment. Okay, so my k should be greater than or equal to I1, right? So in the similar manners, my k should be greater than or equal to n minus IR plus 1, right? So this whole part is n minus I of I, n minus IR length, and this whole part containing the IR is of length n minus I R plus 1. So my k should be greater than or equal to I1, my k should be greater than or equal to n minus IR plus 1, and again, so here as well, so my k should be greater than I j plus 1 minus ij, right? So what this means is that suppose my x is 3, and suppose this is some part of the array, and here again x is equal to 3. So suppose this is index I, this is I plus 1, I plus 2, and here I plus 4, right? So this is I plus 3. So what I can notice is that I have to uh, what I am meaning is that, okay, wait, what I'm trying to say is that, so it is okay if we don't have any x in this interval, right? It is okay if we don't have x in this interval, because we have x here and we have x here. So our k should be such that, so suppose this is I plus 4 minus I is 4. Okay, so if k is equal to 3, then you can notice that here, okay, let me change the color here. If I take the subsegment of length k is equal to 3, my x is not occurring. My x is not occurring. So my k must be greater than 3. So my k must be greater than or equal to 4. So that is the thing. And yes, so basically this is the idea. And for every element x, for every element x, I can find k, right? I can find k. So I will list the element in the uh, increasing order. So I will basically sort the distinct values in the given input. Sort the distinct values in the given input. Start from the beginning. Start from beginning of those values means I will start with the smallest value possible for x, means the smallest value in the array, and I will calculate k for that. Okay, when I will calculate k, okay, when I will calculate k, I can notice that my answer for k plus 1 is also x. My answer for k plus 2 is also x. So for every group which is greater than k, my answer is going to be x, because it is the minimum possible element we have chosen, right? So that is basically the thing. And we will maintain the answer array of n size, n sized. Okay, so basically let us take a look at this sample test case, then you will be, what you can say, you will be more confident for the logic I've explained to carry it with you. And wait, what happened? Okay, just take this further down, and yes, here we go. So n size, so answers array will be of size 8. 1 2 3 4 5 6 7 and 8 again. So set of x will be 1 2 3 4 and 5. So let's start with x is equal to 1. So these are the indices 1 2 3 4 5 6 7 8. And for x is equal to 1, indices are just 6, right? So our k should be greater than or equal to 6, and our k should be greater than or equal to 8 minus 6 plus 1. So basically this is the intersection, k is greater than or equal to 6. So my answer 1. So basically this array will be filled with minus 1 initially, So I'll explain why. So k is greater than or equal to 6 means I can fill all the three values by 1. So 1, 1 and 1. So let us take a look at x is equal to 2. So it occurs at index 5. So in this case my k should be greater than or equal to 5 and my k should be greater than or equal to 8 minus 5 plus 1, right? So my k should be greater than or equal to 5. Okay, so what I can notice is that, so for k greater than or equal to 5, the values k is equal to 6, k is equal to 7 and k is equal to 8 are already filled. Okay, so I will iterate from the k, the value of initial value of k, till where I have minus 1, right? So basically I'll just erase this and put x is equal to 2 here. So this is basically the thing. And for x is equal to 3, it occurs at 2 and 8, right? So 2 and 8. For here k should be greater than or equal to 2, k should be greater than or equal to 8 minus 8 plus 1, and k should be greater than or equal to 8 minus 2. So basically this is the intersection, right? So k is greater than or equal to 6. So again, our values are already filled, so we are not going to fill x is equal to 3 in any of the values. What about x is equal to 4? It occurs at first index, third index and seventh index. So here k should be greater than or equal to 1, k should be greater than or equal to 8 minus 7 plus 1, k should be greater than or equal to 3 minus 1 which is 2, and k should be greater than or equal to 7 minus 3 which is 4. So basically what I can see is that this is the intersection, right? So yes, I can fill the value at index 4 as 4. Yes, what about x is equal to 4? Okay, what about x is equal to 5? And the only index where 5 occurs is 4. So here k should be greater than or equal to 4 and k should be greater than or equal to 8 minus 4 plus 1. So it is basically this is the intersection, right? K should be greater than or equal to 5. But again, all the values for k greater than or equal to 5 are filled. So basically this will be our answer. This is our final answer. This is our final answer. So basically that's the thing. And this is basically the logic, and it is pretty easy to implement. Yes, so let us directly head towards the code. So basically this is storing the indices related to that value, and this is for sorting the elements. Elements in the set are by default sorted. So for every element in set S, this is the temporary vector. So this is for the uh, updating k based on the values in that vector, and these are the initial cases, right? So for here, so these two lines are for, you can easily notice that these two lines are for these things: k is greater than or equal to I1 and k is greater than or equal to n minus IR plus 1. Yes, and this is updating the k further, so f of x further, and finally setting the answer of k is equal to element based on this condition that answer of k is minus 1 from the beginning, and if it is not, we'll break out of that while loop. And yes, a pretty simple code, and finally outputting the answer. I hope you enjoyed solving the question on your own and listening to the solution as well. So this is basically the same idea from the editorial uh, or tutorial, whatever it is. So thank you for watching, and consider liking the video if you found this solution pretty insightful, and stay subscribed, stay tuned to the channel. Thank you for watching. See you again, for sure.